Okay, so the first thing we're going to do is we're going to rewrite / simplify some expressions. And I just realized a mistake. We're going to do it in terms of x and theta only. And so that 64, let's change that to an x. All right, and what we're basically looking at here, if you look at that real closely, that's essentially, let me kind of bring it out over here from the previous note, right? That is basically our 1 plus cosine. So our a, right, is that x. So this is just a fancy way of writing our half angle for cosine. We're just replacing that a with an x. So that was a pretty easy rewrite in terms of what's going on there. So we got that. The next one, we're looking, if we take a look at our identities, we have a sine over 1 plus cosine. So it's definitely tangent. So we're looking at the tangent, right, of 5x all over 2. And so that would be the rewrite for that guy in terms of its tangent, half identity. And then last but not least, we have the square root of 1 minus cosine over 2. Well, that's basically our sine. And there's our a. So we're looking at the sine of that guy, 2 theta over 3, all over 2. And if we multiply by reciprocal, this is 2 theta over 3 times 1 over 2. We see some 2's canceling out, and we end up with theta over 3. Okay, so there, right, is what we would have with regard to that. Let me make sure I did, yeah, so a, and then multiply by reciprocal, 2 is 1/2, yeah. All right, so there we have it. All right, you guys, so there's some rewrites, and that's about, like I said, these things are so hard to use. I think the homework set's pretty basic like that, because they're hard to use. In terms of proving or verifying an identity, I think what happens here is we got to just figure out the right form of tangent to use. So since I kind of see a subtraction and addition there, you know, maybe again we use that form right there. So the tangent of x over 2, right, this is rewritten as 1 minus the cosine of x over the sine of x. And of course, now that I have a subtraction, I can break this down into 2 fractions, right? 1 over sine of x minus 1 over cosine over sine x. And of course, what is 1 over sine x? Well, that's cosecant. And what's cosine over sine? That's cotangent. All right, so we basically have proven that identity pretty quick, right? Just by invoking the right half angle for tangent. For the next one, we got kind of a mess everywhere. But again, since that's a half angle, why don't we start there? And we are using the reciprocal of tangent. So this is basically the reciprocal of tangent. So we know that tangent of x over 2, right? Again, kind of taking a look, we got 1 plus cosine over sine. So I bet you, right, what we need is this guy right here, this middle one. So we know that the tangent of x over 2 is sine x all over 1 plus cosine of x. So this would basically mean that the tangent of squared over x over 2 is sine squared x all over 1 plus cosine, and that part's x. So that's tangent squared. So what do we know about cotangent? Well, it's the reciprocal. So if we basically flip things on its head, the cotangent squared of x over 2 will be 1 plus cosine of x squared all over sine squared x, which is what we got over there. So again, just picking out the right tangent form in what to use. All right. And the next one, how about I start over on this side first? And when I initially look at this, right, we know that cosine squared minus sine squared, well, that's basically cosine of double my angle. So we're basically looking at the cosine of 2 times x over 2. So this side becomes cosine of x. So that's that side. So what we're hoping is that this turns into that. So let's start over here. So I guess equals equals. So on this side, sine of 2x, well, we know that that's sine of 2x times cosine of x. and we're dividing it by 2 sine x. The 2's divide out, the sines divide out, and lo and behold, I was able to make one side look exactly like the other side, cosine of x, cosine of x. So quite frankly, I mean, I know the identities themselves are very awful to look at, but the homework is pretty straightforward because these are just so hard to use. It's be almost malicious to get too crazy on you. I actually think the hardest problems are going to be where you're finding exact trig values, right? Because the math, as we saw earlier, gets a little crazy with regard to trying to simplify the radicals. So that's probably the toughest part of the homework set. Of course, if you need help, you need to ask questions. Jump in on Canvas, pose your ideas, show me your mistakes, give me an opportunity and your classmates an opportunity to correct them, and or come see me during an office hour, and we can try to which way's best. And of course, the worst thing you can do is to not try anything at all. You can learn a lot by making a mistake and restarting and going forward, especially when it comes to tangent to the half angle, because there's 3 different versions. Which one you use kind of depends on lots of different situations. So that wraps that up for the week. I'll see you guys later. Hope to see you on Canvas or in an office hour.